Welcome back, and in this video we're going to start talking about looping structures. So if you haven't read chapter 4 from our textbook yet, I'm going to strongly suggest that you go through and do so and at least cover the while loop section with this particular video. It'll give you a little bit more detail. I'm going to go through it quickly and kind of the setup and how things kind of work with these. So if you haven't done that yet, take a moment and go read those sections out of chapter 4 and then come back to the video. If you have, the while loop is a easy enough loop to understand. A loop is simply a block of code that you can have repeat itself a certain number of times or based on a certain condition being true. And while that certain condition is true, or while it's going to iterate a certain number of times, you can do something over and over and over again. So when it comes to the while loop, at least when we're doing it in a counter-controlled way, we need three things, okay? You need these three things no matter how you set it up, but with a counter control, we need some sort of control variable. So here, let's say I wanted to just set up a loop that's going to print items 1 to 10, okay? My control variable is going to be something like a counter, okay? I can set it equal to some value, but I need that initialized before I begin. This is what we call my control variable. Okay. The second phase would then be the condition statement. The condition statement for a loop, a while loop at least, is going to start with the keyword while, much like our if statement started with if, our selection statements. Our looping structures can start with the word while, and it acts very similar to a selection statement. It's while something is true, we are going to continue to repeat certain blocks of code. So we need a Boolean statement here, and my Boolean statement might be something like this: counter is less than or equal to 10. Okay, that's a Boolean condition. Counter is 1, counter is less than 10, that's true, and while that's true, we're going to keep doing something. So for me, I might do something like this: print my counter, and I'll use my end argument to put everything on a single line. Now, leaving it like that would be not well done, because what you'll notice is that in this loop, we're stuck in it infinitely many times, which we'll talk about again in a second. But what I need to do is make sure in the third phase, I always make some sort of incrementation to my control variable, something like counter plus equals 1. If you haven't gotten into these operators yet, there's some unary operators that allow you to operate on one variable in a very small, succinct way. Here the plus equals 1 simply means take the counter, increase it by 1, and reset the value of the counter to be 1 more than what it previous was. You can go minus equals 1s, times equal 2, divide equals 3, it doesn't make a difference. All of the operations work in this way. Whenever you put an operation, an equal sign, and some value, whether that value be a constant or a variable, it will increase, decrease, multiply by, divide by, whatever it is you told it to do, and reset that variable appropriately. So let's go ahead and run this and just kind of see what we've got. When I run it, you're going to notice that it actually gives me lots of output, 10 different print statements from 1 to 10. Why does that work? Well, let's think about it. Counter's 1. While the counter is less than 10, which it's 1, so that's true, it's going to print it, and then it's going to increase it by 1, which means it's going to be 2. Well, 2 is less than 10, so it's going to do these statements again. And then 3 is less than 10, 4 is less than 10, and finally it gets to 10, and 10 is still less than or equal to 10, so it's going to print the counter. Counter becomes 11, and then it finally ends the statement. And you can prove that counter is 11 if I did a quick print statement and printed out the counter. It would work out just fine. I don't think you necessarily need to see that, but that is what we call a counter control loop. Counter control loops can go in any direction. You want to go from 1 to 10, 0 to 20, 0 to 50 by 2s. You absolutely can do that. You just have to change certain things about this. So if I wanted to go by 0 to 50 by 2s, I can change that to 50. I can change this to increase by 2, and I'll see that it works just fine, and I get every digit 0 to 50. If I want to increase, decrease, do multiples, I can do any of that just as long as I have my control variable, my condition is set up to end at some point in time, and I have this incrementation statement. The incrementation statement is absolutely necessary while you're doing those sorts of things. Now, the while loop is also really great and shines when it's used as a condition-controlled loop, something that's maybe based on a condition where you don't know exactly how many times it's going to repeat, but it's going to repeat until you get something that you need. Maybe something like this. Let's go with, we'll get some input. We'll go value equals int input, enter an even number, okay? And while my value, mod2, is not equal to 0, okay? So if I divide it by 2 and there's no remainder, or the remainder is not 0, I should say, I want to get that value again. Let's make that a printf real quick. I just forgot. All right, so let's go ahead and run this. I'm going to comment this out so we don't have to see it again. Whoops. Let's go ahead and just run this section of loop, and you're going to notice that it says enter an even number. I enter 5. Enter an even number, 7. Enter an even number, -1. All of these numbers are considered odd, and I don't know how long this is going to work. Okay, how long am I going to be stuck in this loop? Well, this is where it's condition controlled, based on some sort of condition that the program has in its instructions. It says, I'm going to keep doing this until, of course, I get what I need out of this. So let's say I enter a 10 then, and then it finally ends because I entered exactly what I wanted, okay? So you have to be really careful about that sort of stuff. But the condition controlled loop is really where it kind of starts to shine, where you can enter in something and then maybe it's something based on input, or maybe it's something based on the output of another function, or whatever conditions you have within the loop. But the while loop will allow us to keep going while something might be true. And you'll notice that that happens a lot of times in the way that we speak and do different things. Like we're writing a game, maybe we need this to continue to play while maybe my Flappy Bird is still flying or still alive or whatever it is, or hasn't run into a pipe. So again, that's a condition that we would continue to work on. Now you want to be sure that you avoid the infinite loop as you're going through certain things when you start working with these. So a couple things that you could run into as you're doing these looping activities that I've noticed students making mistakes on is, one, doing something very similar to what we did up here, counter equals 0, while counter is, say, less than 11. Okay, and it just prints the counter, okay, equals space, okay. So the first problem that we often see with these is people not putting in that incrementation to the control variable or changing it in some way. Notice I've got counter 0, but I don't actually make the change. So when I go ahead and run this, it's just printing zeros as far as the eye can see, and my program is still running and running and running, and I need to stop it, okay, in order to get this to finish. So you have to make sure that you do put that counter maybe plus equals 2 in here, or plus equals 1 in there, okay, to make sure that it runs appropriately and gives you the digits that you want. Another issue that you often find is that people often tend not to use the less thans and greater thans appropriately, and they like to go, well, it's not equal to 11. Well, this is all fine and dandy, and it still does the exact same thing. When I run it, I get 0 to 10, but let's say we were just printing even numbers. Well, hopefully you can identify what the problem is going to be here, is that it's going to completely skip over the condition that would have allowed it to exit. Here I've got counter 0, it goes from 0 to 2 to 4 to 6 to 8 to 10 to 12, and it never reaches the 11, which would never allow this statement to become false. Okay, the only way to make this statement false is to make it the 11 on the nose, and since we completely skipped over it and turned it out evens, that's something you need to be very mindful of. So when it comes to controlling loops and making sure that you avoid those infinite loops, you want to make sure that a couple of things happen. You always have to change the control variable and make sure that it has a way of becoming false, and that you write your condition in a way so that you give yourself a broad range of false values, if at all possible. Okay, sometimes that false variable does need to be or that false condition does need to be very specific, but in many cases you can use a broad range of values by using simply less than, greater than, less than or equal to, greater than or equal to, or something of that nature. So keep that in mind as you're kind of working your way through. Now, where the while loop really tends to shine is when you start coming up with validation loops. Okay, let's bring that back and comment it out. Validation loops are a lot like what we did up here. We want to make sure that we keep looping on something until we get the appropriate input that we're looking for. So let's say we're playing a game, and maybe it's a guessing game, and we want to make sure that the person who's guessing is guessing values between 0 and 100. Okay, so we might have like a guess come in. And we want to make sure that this guess is within that range. So we might write something like, while guess is less than 0, or guess is greater than 100, we're going to have them guess again. Okay. This is what we call input validation, where we're making sure that our input is the proper range of values, a proper value, things of that nature. Now, there's nothing in this loop that's going to stop me from entering like strings and characters and Boolean values and things like that, and that's better served with a different kind of validation structure, with something like a try-catch block, where you try certain values coming in and you catch exceptions that would occur, because obviously I'd be trying to enter an integer, and this function will not run if I don't enter anything that's a valid integer, like a float or a decimal or a string. So that would be a little bit different of a setup, but for us, when we know we have the right kind of data going in, at least, we just want to make sure it's in the right form or of the right value. This is a nice, efficient way of doing it. So we write loops so that we continue to allow the user to enter data until they give us the data that we're looking for in our program. There's a nice little saying in programming, garbage in equals garbage out. If you put bad data in, you're always going to get a bad response. So you want to make sure that you always get good data in. So maybe this is a guessing game where I'm guessing numbers between 0 and 100, but I don't want to count guesses that are invalid against the user for any particular reason. This is a nice way for me to get that, and now I can do something with it. And I could say maybe print guess was, right? And so you can see that when I run this now, when I start guessing numbers like 50, which is in the range, it says it right off the bat, no problem. But if I were to guess something outside the range, let's say I guessed 120, it's going to say be sure to guess a value from 1 to 100. -2, be sure to guess a value from 0 to 100. 4, there it is. My guess was 4. It was within the range. My loop didn't run. I'm good to go. So again, I still have all the three parts. I have my control variable. It just gets set via input. I have my condition or conditions. Okay, and then I have my incrementation statement where I'm changing the control variable if need be, and as long as my control variable can reach something that would allow this to become false, anything between 0 and 100 inclusively, it would then exit the loop. And so that's where while loops really tend to shine. You can use them as counter control loops, you can use them mostly as condition controlled loop, and then you can use them to help you validate information. So hopefully that helps. In the next video, we'll talk about for loops to help with that whole counter-controlled structure.